Welcome to Review Recording 1A and B to accompany instructional recordings 1A and 1B for Section 5.2 of Unit 5, Chapter 5 of Mathematics 2200. Here we do some examples on multiplying and dividing radicals, including rationalizing denominators. Example 1, we have simplify completely cube root of 2 over the cube root of 6. Both the numerator and the denominator are monomials. The index is the same, it's a 3 in both. Now we'll check to see if we can divide the radicands. Well, it looks like I can divide both 2 into both 2 and 6. 2 goes into 2 once and into 6 3 times. So we have here the cube root of 1 over the cube root of 3. But we're not finished because if radicals remain in the denominator, we have to get rid of them. To do that, we look at the exponent that's on this 3, which is 1, and the index is 3. So we're going to need to multiply by the cube root of 3 squared. 1 plus 2 gives us the same as the index. And we do the same thing to the top. Can't just change the denominator without changing the top. So in the bottom, we will now have the cube root of 3 cubed, or the cube root of 27. In the top, we will have the cube root, well, 1 times 3 squared is just going to be whatever 3 squared is. So we've got the cube root of 9 in the top. In the bottom, the index and the exponent are the same. They cancel each other out, so we're left with a 3. Our answer is B. For our next one, we have to simplify completely. Notice that we have a binomial denominator. Therefore, we have to multiply by the conjugate of the denominator. So we multiply by 5 plus the square root of 15. And whatever we do to the bottom, we have to do to the top. So we multiply that by 5 plus the square root of 15. In the bottom, because they are conjugates, we don't need to do complete FOIL. We can get away with the square of the first term. That's 5 times 5, which is 25. And negative root 15 times positive root 15 will give us negative 15. We're multiplying a square root by itself, so we lose the root. In the top, however, we've got a little bit of work to do with FOIL, or Benny binomial, as I affectionately know them. Here we go. We got 5 times 5 is 25. Root 15 times root 15 is 15. Then we have 5 root 15 here and 5 root 15 there. Good old Benny's giving us a good smile. So we've got in the top 25 plus the 15 plus the two 5 root 15s to give us 10 root 15. 25 and 15 is 40. So we have 40 plus 10 root 15 all over 25 minus 15 is 10. We can divide 10 into all the terms. So we have 4 plus root 15 all over 1, which is just 4 plus root 15. Answer is C. In example 3, we have to find the area of this rectangle in exact form. The area is equal to the length times the width. The length is 4 root 27 minus root 20, and the width is root 12 plus 2 root 80. Now those numbers are fairly large, and we want to be able to simplify completely. So to help us with that little later task, we're first of all going to express each of those radicals in simpler form where we can. Root of 27, we think of that as root of 9 times root of 3. Square root of 9 is 3 times 4. So that gives us 12 root 3. Square root of 20. That's the square root of 4 times the square root of 5, which gives us 2 times the square root of 5. Square root of 12 is the same as the square root of 4 times the square root of 3. Notice I'm picking the largest perfect square factors of these radicands. So the square root of 4 is 2, so I've got 2 root 3 here, and 2 root 80. That's 2 times the square root of 16 is the largest perfect square of a factor of 80. 16 times 5 makes 80, so I've got 2 times 4 times root 5, which gives us 8 root 5. So this problem up here becomes 4 root 27 is now 12 root 3, and minus root 20, that's minus 2 root 5. Root 12, that's 2 root 3, and 2 root 80 is 8 root 5. Now we've got a little bit of FOIL work to do. 12 root 3 times 2 root 3. That's 24 root 9. But hopefully you recognize the square root of 9 is 3. So we've really got 24 times 3 for that part. So minus 2 root 5 times 8 root 5, that's minus 16, and root 5 times root 5 is the root of 25. But again, multiplying a root by itself, we're going to end up really just losing the root. So we've got minus 16 times 5 for that multiplication. Now I've got to multiply negative 2 root 5 times 2 root 3. That gives me negative 4 root 15. And 12 root 3 times 8 root 5 is 96 root 15. So I write these down below. 24 times 3 is 72. 16 times 5 is 80. And these two are like terms, so I'm going to have plus 92 root 15. 72 minus 80 is negative 8 plus 92 root 15. When dividing radicals, ensure the radicals have the same index first. If radicals remain in the denominator, follow the appropriate process for rationalizing. And when rationalizing denominators, there are two cases: if the denominator is a monomial and if the denominator is a binomial.